In this tutorial, I'm going to talk about bean definition inheritance. This is not bean inheritance, it's bean definition inheritance. What this means is, say you have a lot of bean definitions in your Spring XML. You have like 100 beans and you have definitions for all of them. And let's say you have some things which you do common across a whole lot of beans. There is a common set of values that you'll have to initialize across multiple beans. Then bean definition inheritance can be handy. What you can do is you can have one bean which contains all these common definitions inside it, and then you can inherit all the bean definitions across your other beans. Now this parent bean, which has all the common definitions, that can be a bean in itself, or it can be an abstract bean definition, which means that there are no beans created for it. All it does is it serves as a purpose of templating your bean definitions. So it's a handy feature if you have a lot of beans and you have common things that you initialize across different beans. So we're going to have a look at that. Now I have this triangle bean which has initializations of 3-point objects. In order to demonstrate bean definitions, what I'll do is I'll create a parent bean definition which contains the configuration for point A, and then I'm going to create a child bean definitions which inherits from the parent, which inherits the point A configuration, and it adds point B and point C configurations to that inherited definition. So let's call this as id equals, I'll call this parent triangle, and the class is going to be the same. Well, in fact, let me copy this, and I will close the bean definition here. Okay, so I have a parent triangle definition which defines the value, the reference, for only one of the 3 points inside the triangle object. See, the triangle object has 3 points. All the 3 have to be defined. But in my parent triangle bean definition, I'm defining only one of those points. Now I can have as many number of triangle beans as I want, which inherit from this parent triangle. And since I inherit from the parent triangle, I don't have to configure the point A property because it's already configured to point A. Of course, if I want it to be different than this bean, which it's actually referring to over here, if I want a different bean to be referenced, then yes, I'll have to configure the point A as well. But if I'm okay with this point being configured over here, then I do not have to make a configuration for point A as long as I inherit from this parent triangle. So to demonstrate that, what I'll do is I'll define triangle 1, and here I'm not going to specify the point A configuration. It's just going to be point B and point C. Okay, and I'm going to have triangle 2. That's again going to configure point B. I'm not going to configure point C here, just to show you how it can be done. Okay, so I have triangle 1 which inherits from the parent triangle. In order to inherit the bean definition, what I do is I say parent equals, and I give it this name, which is a parent triangle. Okay, so this bean definition, the bean ID triangle 1, has a definition that inherits a definition from the parent triangle. So all the configurations of this bean are going to apply to triangle 1. Now I can do two things here. I can add additional configuration over here. Say here I'm adding point B and point C, or I can actually override some of the configurations. Say I have a huge list of configurations over here and I want one of them to change. I can specify the property here, and then that is a property that's going to get considered, and then that will override the property over here. Since I have only one property here, there's really no point in overriding. I'm going to leave it as it is, and this in essence is inheriting the definition of the parent triangle. Now again, triangle 2 is going to inherit parent equals parent triangle. So this is again inheriting from this, and point A is something that inherits. I don't have to configure it. I'm configuring only point B. Now if I run this, let's say I'm going to do a get bean for triangle 1 alone. So let me do a get bean for triangle 1, save, and if I run this, you can see that triangle 1 has all the 3 points configured inside it, even though the Spring XML has only point B and point C configured. This is happening because inheritance is happening here. It's inheriting the point A configuration from the parent triangle. Now let's say I initialize triangle 2. So let's say I do a get bean for triangle 2. Let's save and run. So note here that point A and point B are there. Point C gives a null pointer exception. That's because point C has not been configured in triangle 2. But even though point A is not configured in triangle 2, it has the value 0, 0 because it's inheriting from the parent triangle. So this is a handy feature if you have a whole lot of configurations and you have some common configurations across different beans. One additional feature of bean definition inheritance is, let's say you have a list here. So instead of 3 different point member variables, let's say I have a list of points. Okay, and let's say I call this points. We won't be having this. So we've seen how this works before. We could initialize a list of references. So instead of having a single property and a single reference, what we would have is a list here. Okay, I can have as many references as I want. Let's say I have a ref bean equals point A. Okay, so I'm creating a list in the parent object. Now the advantage is you can inherit the list as well. Not only can you inherit the list, you can add to the list if required. So what we need to do is, let's say let me remove these 2 here. So what I can do is copy and paste this. Okay, so here, let's say I define a point B. Okay, so I have one element in my list. So this property member variable is a list. Okay, so I have one element defined in the parent bean, and I have one element defined in the child bean. Now what would happen is, since I'm defining the element for the same member variable, point B would override point A. So triangle 1 would have just point B reference, just one element in the list. Now let's say I want to merge point B with whatever has been configured in the parent bean. Now say I have 10 elements in the parent bean. I just want to add one element to that parent in my child bean. So I can do that. I can actually merge collections. This works not only for list but also the other collection elements. Here in the list tag, all I need to do is say merge equals true. So this is going to merge the elements that are defined in the child bean to the elements that are defined in the parent bean. So this is a special condition here. Normally what happens is you define a bean property and you define the same property in the child bean. This is going to override. Okay, the old value is going to go and the new value is going to override. But in the case of collections, there is an option where you would want to merge the collections. So say you have a collection property here. In the child bean, if you have the same collection property and you have merge equals true, it's not going to override. It's just going to add whatever elements are there in this child collection. And finally, there is one more point. Say you have a parent bean here which you do not want to be initialized. You just want it as a template. So you can have a property here called abstract equals true. So in that case, what Spring is going to do is it's not going to create a bean of this particular ID. It's just going to use it as a template, and all the child bean definitions can use the bean definition of this one, but it's not going to create a bean of parent triangle. This is handy if you're using a bean just as a reference, as a place where you consolidate all the common configuration. You don't want the bean to actually be initialized.